Okay, some basic definitions. PA is probability of A. It's the probability that event A occurs. A is an event that contains K outcomes. So number of outcomes is K. S is the sample space, which we said could be head or tail, or 1 through 6 for tossing a coin and rolling a die respectively. If A is an event containing K outcomes, S is the sample space containing N equally likely outcomes, probability of A is simply K over N. So if this sounds a little abstract, let's take an example. Let's assume we're looking at tossing a coin. So how many outcomes do you have from tossing a coin? 2 outcomes, right? Total number of outcomes is 2. So that's actually the size of the sample space. So N is 2. But your event could be getting 1 out of those 2 outcomes, which could be head or tail. So let's assume the event we want is head. So that's just 1 out of the 2 outcomes, right? So K is 1, and the total sample space, the dimension of the total sample space is 2. So what's probability of getting head? So A is head, right? It's K, which is 1, divided by N, which is 2. And you're done. What if it's rolling 6 on a fair die? So the probability of rolling is 6. 6 is 1 out of all the outcomes. So K is 1 still. But what's the size of the sample space? How many items are in the sample space? It's 1 through 6. So there are 6 of them. So there's a 6. And then the probability is K over N, which is 1 over 6. What's the probability of 2 outcomes, which is of getting a 4 or a 5 when you roll a die? So now the number of outcomes is 2, not 1. It's 4 or 5, right? And then number of outcomes is still 6. So now it's 2 over 6. The probability of getting 4 or 5 is 2 over 6, which you can also calculate as probability of getting a 4, which is 1 over 6, plus probability of getting a 5, which is 1 over 6, which is also 2 over 6, and 2 over 6 is 1 over 3. Good. Probability of A complement is everything outside of A, right? So if this is A, it's everything else in the set outside of A. And that's basically 1. That probability is 1 minus probability of A. Why? Because probability sums up to 1, right? So if probability of rolling a 6 is 1 over 6, probability of A complement is 1 minus that. And that's precisely equal to probability of getting 1, 2, 3, 4, or 5. Right? All but a 6. And that's 5 over 6, because probability will sum up to 1. For any event A, probability varies from 0 to 1. So not only will all the probabilities sum up to 1, each probability for each outcome has to be within this interval between 0 and 1. It can be greater than 1, it can be negative. If A and B are mutually exclusive, so they do not intersect like we talked about, so these will be A and B that do not intersect, they do not overlap, then the probability of the probability of A union B, so probability of the union between A and B is just probability of A plus probability of B, right? You just add them, they are mutually exclusive, so you get this probability and add it to this. Whereas if they are not mutually exclusive, meaning there is an overlap like we talked about previously, there is an overlap between A and B, then you don't want to count this part twice, so you will need to take out the probability of A intersection B in that case. So this is the exact expression. We have taken out the intersection so you don't count it twice. It's part of A, it's also part of B. Probability of A intersection B, which is the shaded part, is basically the probability of A multiplied by the probability of B. And we talked about that A intersection B is basically A and B. And when you say and, when you use and operator on probabilities, it's equivalent to getting the probability of A and multiplying. So and means multiply. Or, say A or B. Or means add. So if you want probability of A or the probability of B, you add. If you want both probabilities, probability of A and probability of B, you multiply. Important concepts in probability. And the assumption for probability of A and B being this product is that A and B are independent. And we'll talk about what independence means after briefly introducing conditional probabilities, and then we'll go deeper into what conditional probabilities are shortly. So now we turn our attention to fundamental principles of counting. So if an operation can be performed in n1 ways, you can perform an operation in n1 ways. That's the total number of ways we can perform the operation. If for each of these ways, meaning for each of these n1 ways, a second operation can be performed in n2 ways. So for each of these n1 ways, we can perform another operation in n2 ways. Then the total number of ways to perform both operations 1 and 2, is the number of ways of performing the first operation multiplied by the number of ways of performing the second operation. Because for each n1 operations, you can perform each one n2 ways. So this will be the total number of ways to perform the operation. So you don't have to count it by hand. You just use this rule. Assume that k operations are to be performed. If there are n1 ways to perform the first operation, so we want to perform k operations, and then we're giving some extensions of this principle. So this extends it further out. There are n1 ways to perform the first operation. For each of these n1 ways, there are n2 ways to perform the second operation. And if for each choice of ways to perform the first two operations, so n1, n2, there are n3 ways to perform the third operation. So we are extending it out. And then that will give you a total number of n1 times n2 times n3 ways, right? If this continues to n4, right, and then to nk, which is why I said there are k operations to be performed. In this case, k was equal to 2, just two operations, n1 and n2. Here there are k operations, so you'll do n1 times n2 times n3 all the way to nk. And this is the total number of ways to perform the sequence of k operations. I hope that's clear. So we've just extended this case, which is a simple case with two operations, to a case with any k operations. Now we give an example of what a problem testing you on this understanding could look like. And these are the kinds of questions you can see in your quiz or midterm or final exam. A certain make of automobile is available in any of three colors. It's red, it's blue, or green. Three possible colors. So those could be your first operation. There are how many ways of performing this first operation? How many ways of selecting a car of a given color? 3 ways, right? Red, blue, or green. So that's the first part of the statement. And comes with, so let me read it all over again. Escape. A certain make of automobile is available in any of three colors, red, blue, or green, and comes with either a large or small engine. How many options do you have there? 2. So N1 is 3. N2 is 2 because it can either be large or small. Nothing else. Now, you tell me, how many ways can a buyer choose a car? Straightforward, right? The answer is right here. N1 times N2, right? So there are 3 colors. That's N1 times N2, 2 sizes, large or small. So number of ways a buyer can choose a car is 6. And this could be in any different form, right? It could be 7 possible sizes and 3 colors, and that will be 7 times 3. It could be 7 possible sizes, 3 colors, 2 engine types, and then it will be 7 times 3 times 2. You keep multiplying all possible operations or options, in this case of choices. And that will take us to permutations. A permutation is an ordering of a collection of objects. So very important to realize that when we talk about permutations, order is important. So link permutations with order in your mind, because shortly we will talk about combinations. And with combinations, order is not important. With combinations, we just care about selection. The number of ways you can make a selection. And they're not the same. It's not equal to that. With permutations, order is important. And so, if you have 3 letters A, B, C, you can order them in 6 possible different ways. They could be written as A, B, C. It could be written as A, C, B, B, A, C, B, C, A, and so on. 6 different permutations, 6 different ways to order them, and they are all considered distinct and different. But with combination, we don't care about ordering. So with combination, there is only a selection of 3 letters. It's just A, B, C. We don't care whether A comes first or B comes first or C comes first. Order is not important in combination. And when we talk about combinations in more details, you see what the difference is. So we focus on permutations where order is important. And how do we know? Can we come up with a simple way to make this kind of calculation to determine the total number of permutations without having to lay it all out and count manually? Yes. So there are 3 letters, right? How many different ways can you arrange 3 letters? Think about it in this way. You want to arrange 3 letters, right? So these are the 3 possible, these are the 3 possible positions for A, B, C to occupy. So the first question is, how many different letters can fill up this first position? 3, right? A, B, or C could start. So 3. Now, A, B, or C has started these 3 letters. So how many letters do you have left? 2, right? It's A, B, or C. The first could have been A, and then you are left with only B or C. The first could have been B, and then you are left with only A or C, right? Or the first could have been C, and you are left with only A or B. In either of the 3, in any of these 3 cases, 1 letter will be selected and you are left with only 2 letters, which could either be BC, AC, or AB. So only 2 letters can fill up this position, right? So we write 2 here. And then when 1 letter fills this first one and you are left with 2, and one of the 2 has filled this position, how many letters are you left to fill this one? Just 1, right? And how do you get the total number of, how do you get the permutation? You just multiply. So it's 3 times 2 times 1. 3 ways to fill the first position, only 2 ways to fill the second position, only 1 way to fill the last. And that product is your 3 times 2 times 1, which is related to your principle of counting. N1 number of ways to perform first operation, number of ways to perform second operation, and in this case we had 3 operations. Number of ways to perform the third operation is n3. So we come down here, number of ways to fill in the first position is what? 3, right? Because there's A, B, and C. And because you've selected 1 out of the 3, you have only 2 left. Number of ways to fill the second position is 2. You selected 1 more, so you're left with only 1. Number of ways to fill the last position, only 1. N1 times N2 times N3. And then the permutations is 6. Good. So number of ways to order 3 objects. It doesn't have to be ABC. Any 3 objects is 3 times 2 times 1. And then we can generalize this to obtain the number of permutations of a collection of n objects. This was 3 objects, and it was 3 times 2 times 1. What do you think 4 objects would be? 4 times 3 times 2 times 1, right? Only 4 ways to fill in the first position. Then 3 for the second, 2 for the next, and 1. What if there are 5 objects? It's going to be 5 times 4 times 1, and so on. What if there are n objects? Then it's n, and then the next number is 1 smaller than that, right? Times n minus 1, right? And so on. And this will be n minus 2, n minus 3, 3, down to 5 times 4 times 3 times 2 times 1. So that's the generalization. And this product is called a factorial. So when you're multiplying a number by 1 smaller than it, by 1 smaller than it, and so on, what you're calculating is called a factorial. And so 5 times 4 times 3 times 2 times 1 is 5 factorial. 4 times 3 times 2 times 1 is 4 factorial. 3 times 2 times 1 is 3 factorial. 2 factorial is 2 times 1. 1 factorial is 1. How about 0 factorial? Well, it's not 0, it's also 1. So 1 factorial is 1, 0 factorial is 1, 2 factorial is 2 times 1, 3 factorial is 3 times 2 times 1, 4 times 3 times 2 times 1, and so on. So n factorial is precisely this. N times n minus 1 times n minus 2, each number gets 1 step smaller. And last question for this video, how many different ways can you arrange 5 people in a line? So arrange indicates order, and those are the things you watch out for to figure out whether you should use permutation or you should use combination. How many different ways can you arrange 5 people in a line? There are 5 people. How many ways can you put 1 person in the first position? Remember, it's the principle of counting, right? N minus is n1 times n2 times n3 times n4 all the way to n5. This is first position, second position, third position, fourth position, fifth position, and that's your line. So how many people can be in the first position when you're looking for 5 people in a line? The 5 people, right? So 5 people. Any of the 5 could occupy the first position. Since one of the 5 has occupied the first position, how many people are you left with? 4. So only 4 can occupy the second, and then 1 person has occupied the second position out of the 4. So you're left with 3. 3 people can occupy the third position, then 2 can occupy the fourth position, and only 1 person can be in the last position. And what's this? 5 factorial, which is what? 20 times 3 is 60 times 2, 120, and you're done. And then we'll continue from here in the next video. Wow.